So let's go through some examples on how to determine if a relation is linear, quadratic, or neither, given a table of values. So how do we do that? Well, if you look at the difference in the y values, and you take the difference of each of those, if the first difference is consistent, then it is linear. If the second differences are consistent, then it's quadratic. And if neither of those are consistent, it is neither linear nor quadratic. So let's go through an example. If we have 6 and 0, the difference of those is 0 minus 6 is negative 6. 12 minus 0, the difference of those is 12. 42 minus 12, the difference of those is 30. And 90 minus 42, the difference of those is 48. So we see that this isn't consistent. So all these values are different, so it's not linear. One important thing to remember is that you also want the differences of the x's, the first difference of those, to be linear. If they're not, then you're going to have a difficult time figuring out if it's linear or quadratic. So here, if instead of negative 2 here, we had 0, then this difference is 1, whereas the rest is 3. So that would be really difficult for us to figure out. So let's go through the second differences. So the second differences, we're going to look at the linear column and do the differences of those. So 12 minus negative 6 is 18. 30 minus 12 is 18. And 48 minus 30 is 18. So since these values are all equal, then we know that our relation is quadratic. If none of these values were equal or one of them was different, it would be neither then. So let's go through another example. So looking at the x value first, we see that each of these is difference of 2, so we don't need to worry about it then. Then we look at the y values. So 1 minus 0, the difference of that is 1. 8 minus 1 is 7. 27 minus 8 is 19. And 64 minus 27 is 37. So we see that these aren't equal, so it's not linear. So then we're going to go through and take the differences of all of these first differences and see if they're equal. So 7 minus 1 is 6. 19 minus 7 is 12. And 37 minus 19 is 18. So we see that these are not the same values, so it's not quadratic. So it is neither. So if we look at these values, we notice that the difference of the quadratics is 6. So what that actually means is that this is a cubic. We don't need to know that for quadratics. That's just a side note. So let's go through another example. Looking at our x values, we see that it's always increasing by 1, which is good. So looking at our y values, the difference of 4 minus 3 is 1. 7 minus 4 is 3. 12 minus 7 is 5. And 19 minus 12 is 7. Looking at these values, they're not all equal, so it's not linear. So let's look at the second differences. So 3 minus 1 is 2. 5 minus 3 is 2. And 7 minus 5 is 2. So these values are all equal, so it is a quadratic. So let's look at another example. We look at the x values first. We see that they are consistently increasing by 1. Then we look at the y values. So 5 minus 4 is 1. 6 minus 5 is 1. 7 minus 6 is 1. And 8 minus 7 is 1. So since these values are all equal, it's linear. So linear is when the first differences are all the same. Quadratic is when the second differences are all the same. And neither is when the first and the second aren't the same. So how do we determine the direction of opening of a quadratic? So there are two shapes of quadratics, or two openings of quadratics. The first is an upwards opening, and then the second is a downwards opening. So if the opening is up, how do we determine that? So if we look at an equation of y is equal to ax squared plus bx plus c, how do we know that it's opening? By looking at that equation. And we do that by looking at the a value. Why do we look at the a value? Well, what we want to determine is where the equation is going towards. So on this right-hand side, where are we going towards? Are we going to positive infinity, or are we going to negative infinity? So upwards is going to be going to positive infinity, and downwards goes to negative infinity. If we look at the c value, c is never going to be the biggest value as x gets bigger. Because even if c was a really big value, x can go even bigger. X can go all the way to infinity. So c is never going to be bigger than x. So we can kind of just ignore the c value. We know that that's not going to show us the opening. So if we look at this x squared and this x value, which one of those is going to be telling us if it's opening up or down? Well, x squared is always going to be bigger than x. So if you have a value, x, and you multiply it by itself, it's always going to be bigger than what it originally was, unless x is really small. But we want to know as x gets really big what happens. So we don't care about the small values. So here we can ignore this x value because it's not going to be the biggest value either. So what that means is that this term here, this ax squared, that is what's going to determine if our quadratic opens upwards or downwards. So if it opens upwards, this a value needs to be positive because this x squared value is always positive. So as x gets really big, so as it goes to infinity, or really big numbers, then if a is positive, then y is going to be positive, right? Whereas if a was negative, then y is equal to ax squared. That's going to get really, really, really negative, right? So if we think of y is equal to negative 10,000 x squared, this x squared value is always going to be positive, right? So that's always positive. So then this value here is what determines that y is going to be negative. So here, as x gets big, y is going to get really negative. So the takeaway from this is that if your a value is greater than 0, it opens upwards. If your a value is less than 0, it opens downwards. One way I always thought of this was that when you are a very positive person, you're happy. So that's a smiley face. So this smile is your quadratic. And when you are down or negative, then you're sad, right? So that is a downward opening quadratic. Takes a little bit of imagination, but that's how I've always remembered it. So let's look at another table of values. And here we're going to look for the y-intercept. We're going to look for the direction of opening. And we're also going to look for the zeros, if we can find them. The zeros, remember, are the x-intercepts. So if we fill in this table, we sub in the value negative 4 for x. So negative 4 squared is positive 16. So we get positive 16. 2 times negative 4 is negative 8. And then minus 3. So the value of that is going to be 5. Negative 3 squared is 9. 2 times negative 3 is negative 6 minus 3. So the value of that is 0. Subbing negative 2 into our equation, negative 2 squared is 4. Negative 2 times 2 is minus 4. And then minus 3. So that is going to be negative 3. Subbing negative 1 into our equation, negative 1 squared is positive 1. Negative 1 times 2 is minus 2. And then our minus 3. So the value of that is negative 4. Subbing in 0 into our equation, 0 squared is 0. Plus 2 times 0 is 0. Minus 3. So that's negative 3. Subbing 1 into our equation, 1 squared is 1. 2 times 1 is 2. Minus 3. So that is going to be 0. And then subbing 2 into our equation, 2 squared is 4. Plus 2 times 2 is 4. Minus 3. And the value of that is 5. Before we even graph this, if we look at our equation, we see that our a value here is positive 1. So we know that the direction of opening is upwards. We'll confirm that when we graph, but that is what we're expecting. If we look at for our y-intercept, so where does our y-intercept happen? Remember that the y-intercept happens when x is equal to 0. So looking at our table of numbers, we see that when x is equal to 0, our value is negative 3. So our y-intercept is at negative 3. And then looking for our zeros, where do the zeros occur? So the zeros occur when y is equal to 0. So somewhere along the x-axis. So looking at our y values, we see that we have two values where y is equal to 0. So our zeros are going to be negative 3 and 1. So from this, what can we determine? Well, we're going to be able to graph it, but we can also determine where our zeros are, which means we can factor this. So to factor the equation, since our a value is equal to 1, and we know that our zeros are negative 3 and 1, we're going to have x minus our first root. So our first root was 1, times x minus our second root. So our second root was negative 3. So it's going to be plus 3. So that's our factored form. So how do we graph this? Well, let's look at our zeros first and plot those. So we have a 0 at negative 3, and we have a 0 at 1. That means that our axis of symmetry is going to be at negative 1. Remember, the axis of symmetry is just where the vertex is going to end up being. So then we can plot some other points on here. We know that our y-intercept was negative 3, so we're going to have that value. And then we can plot the rest of our points. So at negative 4, our value was 5. Negative 3 we already have. Negative 2, our value is negative 3, which makes sense because remember, our axis of symmetry, it acts like a mirror, right? So then our value at -1 is -4. And since that's on our axis of symmetry, that's going to be our vertex. Then we have at 0, we have -3. We already have that on there. 1, the value is 0. And at 2, the value is 5. So we can just connect all of these lines, all these dots. And it's going to continue off. So that's our parabola, or our quadratic. So just from that equation and the table of values, we are able to get our axis of symmetry, our y-intercept, our zeros or x-intercepts, and our opening. Since we had our zeros, we were able to get our factored form. And since we had our axis of symmetry and a point on that axis of symmetry, we were able to get our vertex. So let's go through another example. So state the direction of opening. Well, we look at our a value here. Our a value is less than 0. Remember, negative a values, negative people are sad. So that's going to be an opening downwards. So we have our direction of opening. To get our y-intercept, let's fill out the table of values. So -7 squared is 49, times -1 is -49. -7 times -8 is 56, and then minus 12. So if we add all those together, we get -5. If we sub in -6, so -6 squared is 36, times -1 is -36. -6 times -8 is 48, and then minus 12. So if we add all of those together, we get 0. Then we have 5 squared is 25, or -5 squared is 25, times -1 is -25. -5 times -8 is 40, minus 12, that's going to be 3. -4 squared is 16, times -1 is -16. -4 times -8 is 32, minus 12. So our value from that is going to be 4. -3 squared is 9, times -1 is -9. -3 times -8 is going to be positive 24, and then minus 12. So the value for that is going to be 3. So -2 squared is going to be 4, times -1 is -4. -2 times -8 is positive 24. Nope, is positive 16, minus 12, and that value is going to be 0. -1 squared is 1, times -1 is -1. -1 times -8 is positive 8, minus 12. That value is going to be -5. So from this value, table of values, what all can we determine? Well, we can't determine the y-intercept yet. Why can't we determine that? Well, we would need x to be 0. So we could extend this to figure out what our y-intercept is. So to do that, we would sub 0 in as our x value. So 0 squared is 0, times -1 is still 0. 0 times -8 is 0, and minus 12. So then our value would be -12. So if we just look at the equation, how do we determine the y-intercept? Well, y-intercept's always when x is 0. So when x is 0, this first term is going to disappear, and the second term is going to disappear. So the y-intercept is always just the c value. So in this case, -12. So we had our direction of opening was negative, so it's down. Our y-intercept is this minus 12. Can we determine our zeros or our x-intercepts? The x-intercepts happen when y is equal to 0. Remember, the x-intercepts are going to be along the x-axis. whereas our y-intercept is along the y-axis. So then looking at our table of values, is there values where y is equal to 0? Well, we see that there are two values here where y is equal to 0. So those are our two zeros. So our zeros are at -6 and at -2, which means that we can factor this equation. Since we have a -a, we can pull that out. So it's -1. And then x minus our first root. So x minus -6 would be x plus 6. And then x minus -2 would be x plus 2. So then that's our factored form. So we have our zeros, we have our intercept, we have our direction of opening, so we can graph this. So let's graph our zeros first. So our zeros are at -2 and -6. Our y-intercept is at -12. It'll be way down here somewhere. And then the average of our two zeros is our axis of symmetry. So here is our axis of symmetry. And everything to the right of it better equal to everything to the left. So then let's add the rest of our points in. So at -7, our value is at -5. At -5, the value is 3. At -4, the value is 4. And since it's on our axis of symmetry, this is also our vertex. At -3, the value is 3. At -1, the value is -5. And we already have our y-intercept on there. So then if we just connect the dots, we have our parabola or quadratic.